Alright, good evening. We're on day number 7. And the problems today, fairly straightforward, not too difficult, but also not very exciting. But we'll try to have fun. See what we can do. So number 1, it's talking about how many 3/5 cup servings of fruit juice can we get from 6 cups of fruit juice. Okay, so the first thing we'd have to look at there is we have 3/5. What does that mean? Well, we can turn that into a decimal. So you can take a second and you can divide out what's 3 divided by 5. Think about what that is here. And once we get that, we can think how many of those serving sizes can we get from our 6 cups of juice. Let's see. Hopefully we're pretty close to getting our answer there, because I'm almost done over here, working really hard. I think I'm missing a pinky there, but whatever. There's my guy pouring juice. I know, I'm pretty talented. There's our juice. Alright, so hopefully we worked this out. We should have gotten 0.6 cups. So it's 0.6 cups of fruit juice that goes in each cup. Let's draw ourselves a cup here. And here's our cup. And we can fill that up. We're putting 0.6 cups in here. So how many of these 0.6s can we get out of 6? So we can say 0.6 times what equals 6. Or if you don't know that, we could work backwards and say what is 6 divided by 0.6. And we never want to divide by a decimal, so we can move that decimal place over. That didn't come out that good. Need a skinnier marker. So we can move that decimal over one place while I'm working not too hard anymore. Okay. So we move this over one place. So we move the decimal on the inside over one place, and now we have how many times does 6 go into 60? Well, that's pretty obvious. That's just 10. So how many 3/5 cup servings can we get from 6 cups? We can get 10 cups. Yay! All right. Perfect. Number 2. A haircut costs $6, which included the tax. Joan tipped 20% and paid with a $50 bill. What was her change? So one thing we gotta remember, there's probably gonna be a few steps in here, but we want to remember our goal is to figure out how much change did she pay, or how much change did she get back. We don't pay change. So we can start. She did pay $16 plus a 20% tip. So how can we figure out what this tip is? Well, it's a percent, and we've dealt with tip problems before, and that usually involves writing a proportion, comparing the tip to the total. So our total percent is 100. Our tip percent is 20. The amount she paid, the total cost, was $16, and we want to know how much was that tip. So we could cross multiply this, but I'm looking at 20 over 100, and it's pretty obvious I can simplify this. I can simplify it just by taking off 1 0 and saying that's 2/10, or I could simplify it even more and say this is just 1/5. But let's not. Let's leave it at 2/10, because we can divide by 10, and that should be pretty easy. So let's say, what's 2 times 16? 16 times 2, that's 32. And now we just need to divide that by 10. So how many times can 32 go into 10? That'd be 3 point. 2 left over. Bring down to 0. Be 3.2. And that's all there is. So our tip is $3.20. That's the tip. So we can add that to the total. So we can say, what is $16 even plus 320? That'd be $19.20. Remember, when we add decimals, we do have to line them up. So this is what she paid. She paid $19.20, and she paid that with a $50 bill. So if this is what she paid with a 50. How can we figure out how much change she has? Well, we can find the difference between those two. We can say, what is $50 if we take away what she paid? We should get, or we should end up with what she got back. Oh my. Having trouble with straight lines today. Okay. 0 minus 0 is 0. 0 minus 2 we can't do, so we're going to have to borrow. So this will become 4, 10. Borrow from 10, so that becomes 9. 0 becomes 10. 10 minus 2 is 8. Decimal. 9 minus 9 is 0. 4 minus 1 is 3. So if she paid with a $50 bill, this is what the store took. This is what she would get back. She would get back $30.80 in change. Or she could have saved herself some time and she could have cut her hair herself. Kind of like this old kid right here. I know what you're saying. How am I not an artist? It's amazing. My talent. Right there. Okay. Number 3. Isosceles triangle. Isosceles. What is isosceles? I don't even want to go any further without knowing what isosceles means. Remember, isosceles means two sides are the same, or two sides congruent. So we can, alright, let's keep going. Isosceles triangle with a base length of 0.17 meters, congruent legs of 12.7, and a height of 8.8. So we can draw this. Now we can say isosceles, let's make this side the same as this side. So our base is 0.17 meters, and our congruent legs are 12.7 centimeters. And a height of 8.8. So remember, height has to make a right angle with the base, so it's going to come straight up and down here. And that's 8.8 centimeters. So I don't know, what is the perimeter? Well, perimeter is just the distance around the outside, so all we're going to care about are these blue sides. We don't really need to know what the actual height is. But hopefully we notice something, that I have centimeters, and then I have meters. That's not going to work. I can't add centimeters to meters, so something's got to change. Since our problem says do it in centimeters, let's change this into centimeters. So in case you don't have your chart, we know that 1 meter is equal to 100 centimeters. So if we need to convert that, we can just consider, how does our decimal point move here? It's a good thing about metric, the numbers don't change, it's just the decimal place that gets moved. So it went from right here in meters to right here in centimeters. So to move from meters to centimeters, all we gotta do is take this decimal and go 1, 2 places to the right. So if we have 0.17 meters, we can go 1, 2 places to the right. So 0.17 meters is going to be exact same as 17 centimeters. So now we can find perimeter. We just have to add these three numbers together. So we're going to have 12.7 plus 12.7 plus 17. Again, remember, if we're adding, we have to line up these decimals. Even though we didn't see 0.0 here, doesn't mean it doesn't exist. So add these together, we get 4 or 14, carry the 1. This is 3, 5, 12. And then 1 plus 1 plus 1 plus 1 is 4. So we get a perimeter that looks like 42.4 centimeters. Right. Number 4. So Adrian, Addie, whatever her name is, she's got a new coffee cup. The diameter of her cup is 4 inches and has a height of 5 inches. What is the volume of her coffee cup? So let's give her a coffee cup. Okay. And we'll give it a handle so she can hold on to it. And give it a little message that says I heart. Yeah, what does she heart? I think she hearts math. Because who doesn't heart math? Yeah, we can put some coffee in here. She's starting her day off. She needs her coffee. It's nice and warm. Okay, that was fun. Let's do math now. So the diameter of this cup, the distance from left to right all the way across, is 4 inches. The height of her cup is 5 inches. What is the volume? So we know volume of a cylinder is the area of the base times the height. And we know that our base here is a circle. So to find the area of the base is really just area of a circle, which is pi r squared. Okay. Now if we look at our circle, let's just draw this out separately so we can see it better. Here is our circle. It had a radius, it had a diameter of 4, but we need the radius. So we need to take half of that. Half of 4 is 2, so we can say our radius is 2. We can fill in the rest. We haven't really done anything with decimals, so let's use 3.14 today. We'll be adventurous. So 2 squared, 2 times 2 is 4 times 3.14. We can multiply that out. 3.14 times not 5, but 4. And if we multiply this out, we get 4 times 4 is 16. 4 and 1 is 4, plus 1 more is 5. 4 times 3 is 12. We have 2 decimal places up top, none in the bottom, so we need 2 decimal places for our answer here. So the area of our base is 12.56, and that would be inches squared. We're not quite done yet, because we still need to find the volume. So we're going to take our area of the base and we're going to put it back into our formula for volume. So this is going to be 12.56. And the height of the whole prism we haven't talked about until now is this 5 inches. So volume is 12.56 times 5. So we can work that out. Let's do this in a different color here. 12.56 times 5. Right, 5 times 6 is 30. 5 times 5 is 25, plus 3 more is 28. 5 times 2 is 10, plus 2 is, blanked out, that's 12. Okay. 5 times 1 is 5, plus 1 more is 6. So I have 2 decimal places up top, none in the bottom, so we need 2 in the answer. So our volume, our final answer is going to be 62.80, and that's inches, and since it's volume, it's in 3 dimensions, so it's going to be inches cubed. Alright, number 5. Ratio of the sales price of a coat to the coat's original price is 3 to 4. The original price is 64. What is the coat's sale price? Well, this is about as simple as it gets. We have a ratio. It's comparing price of a coat, or sales price of a coat, to the original price. So this is a proportion written for you. We have sale to original, and we have, oh, seriously? I hate how it does this. Let's try again. Sale to original. I'm going nice and slow for it. That ratio is 3 to 4. We know 3's got to go on top because it says sales to original, and the order that it's written will always be the same order as it is in numbers. So the original price is $64, so our second half of this can be 64 on the bottom. What is the coat's sale price? That's X. That's it. Now you just solve the proportion. You could conceivably think about what number times 4 will give you 64. But in case you don't want to do that, let's just divide it out. Or cross multiply, divide it out. 64 times 3. That's going to give us 12 and 19. We divide that number by 4. 4 goes into 19 4 times. It gives us 16. 3 left over. Bring down the 2. We do it again. 4 goes into 32 8 times. 8 times 4 is 32. We are all finished. So if the original price was $64, the sale price would be $48. Not so bad. Alright, I'm going to cut it here and we'll start the second part in a different video so this doesn't end up dragging out to 40 minutes. So find the link for that. It'll probably be somewhere down here, maybe over here, possibly up here. Who knows? It'll be somewhere.